physics loving people. I'm back again with another video in quantum mechanics. This video will show you how the superposition of waves, that is matter waves, takes place, and we'll try to understand the superposition principle. We'll also talk about a two-slit experiment with electron for better understanding of the same. This is part 1 of this particular topic. In the later part we'll discuss more about group and phase velocities while discussing this superposition of waves. So let's proceed to understand what the superposition of waves actually mean. We have seen that in quantum mechanics wave-particle duality exists, and this particular concept gives us some indeterminacy in the experimental observations. Indeterminacy in the sense that whatever we measure is not an exact thing. We only say about the most probable value after doing a measurement. So in quantum mechanics we get quantities which are actually while taking the measurement are actually the most probable values. We also note that quantum mechanics cannot characterize some system like microparticle system or simply the atomic system. Here quantum mechanics works and classical mechanics fails, and it's because as we go to the microparticle states, the states cannot be completely determined because we cannot determine the position and momentum in a simultaneous way. And since we need to designate a photon or to represent a state of a photon, we talk about its polarization, or whenever we talk about an electron, we talk about the spin angular momentum about a particular directions. So in quantum mechanics, whatever the values we measure are simply the most probable values. We talk about probabilities, and indeterminacy is always there, and also there are both uncertainty in momentum and positions, and simultaneous measurement of them is not possible. While in the classical methods we can surely explain the states or completely explain the state because we know the trajectory for this particular classical system. And in quantum mechanics, for example, for a photon is represented, or state of a photon is known in terms of its polarization along a particular direction, or a state of electron is known in terms of spin angular momentum of it along a particular directions. So now let's try to understand what is linearity and superposition principle. This principle is something where we have encountered in our differential equation concept also, where we found that if a differential equation has n number of solutions, then the superposition of all the solutions is also another solution of the particular differential equation. So same concept is used here, since while solving the Schrödinger equation we get different numbers of solutions, and if we take the solutions are like psi I, in that case if the individual solutions are psi, then we can say that superposition of all the individual solutions psi r is also another solutions, which is represented by equation 1. So psi is equal to summation ci psi I summation over I. It means that this is a superposition principle, and the superposition of all the states psi 1, psi 2, psi 3 dot all these states together make another state which is also a solution of the Schrödinger equation. And regarding this coefficient Ci, they are simply constants, or they are representing the strengths related with this psi I, because this, when we take the modulus square of this psi I, this will give us the probability density related with the state I, and in that way these C's are simply the strength of these probabilities or the wave functions associated with them. We also note that the equation 1 is a linear equation because there is no higher power on psi I or this psi, because it's this power is 1 here. That's why it's a linear equation. This follows from the fact that the Schrödinger equation is a linear equation in the wave functions. So all the wave functions, the individual wave functions psi are simply linear in order, and that's why this equation 1, which represents superposition principle, is a linear equation. Just like in light or electromagnetic waves, in quantum mechanics, when we talk about the matter wave, the superposition principle is something different, and which could be understood in terms of a two-slit electron experiment. And then we can precisely say that in quantum mechanics we don't know the exact value of an observation, and because of lack of this knowledge, we will see that if a beam of light consisting of one photon is splitting into two beams, then we don't know in which split beams the photon is existing. Only thing that we will say that we can find a probability of finding it in either form. So suppose we have a beam splitter here, a photon is coming, and the photon is split into two parts. Now quantum mechanically we cannot say in which splitting beam the photon exists, and this is what quantum mechanics leads to, which is not possible in classical mechanics. So now we extend the equation 1, removing the summation sign, where this C1 psi 1 plus C2 psi 2, where I is going from 1 to 3 dot dot dot. Equation 2 is nothing, it's simply extended form of equation 1. Now to understand this equation 1, which is superposition principle, we consider a experiment of electron beam with two slits. Equation 2 is now, since we are considering electron passing through two slits, so these two slits will lead to two states for electron, and corresponding to these two states, the resultant state after superposition is equal to psi 1 plus psi 2, where we have dropped C1 and C2 for mathematical convenience. Now while doing this experiment, we have three parts. We can either keep the slit 1 open or slit 2 open, and lastly both the slits can be made open. Now when the slit 1 is open, according to equation 3, the total probability we have to take the modulus square of it, and this side will be absent in that case, because beam 2 is the electron will not be in the second slit, it will be simply in the first slit, so only will consider the psi 1 state, that is corresponding to slit number 1, and we'll drop this one. So modulus square of psi square will be simply psi 1 modulus square. So what is represented by equation 4? So equation 4 is representing the fact that slit 1 is open, and then if slit 2 is open, if we talk about this second option, then in that case this psi 1 will not be there, because slit 1 will not be open, so we will not have any kind of probability with the slit 1, so we'll be only we'll be having probability associated with slit 2, so side will be taken. So probability for the second part of the experiment, that is when slit 2 is open, is this P2, or this side modulus square, is given by equation 5. Now the third one, which is representing simply the superposition of both the states, and the third part of the experiment, where both the slits are open, what comes into our mind is that the total probability associated with that particular experiment is P1 plus P2, but this is not real. In reality, we have to do like this. We have to take modulus of psi square, that means modulus square of psi 1 plus psi 2. If you do all these things, ultimately we are left with equation 6, we see that the total probability when both the slits are open is P1 plus P2, and then these two parts are present there, psi1 star psi2 plus psi1 psi2 star. So this presence of part simply means that this is what quantum mechanics tells us about. Usually probabilities don't add up. Probability actually multiplies, a multiplicatory property. So that's why we cannot take a case of like P1 plus P2, but classically, if instead of probability we talk about intensity, that when both the slits will be open, the total intensity will be say P equal to P1 plus P2. But in quantum mechanics, the total probability when both the slits are open is simply P1 plus P2 plus this part. Thus, quantum mechanics teaches us a very new thing, which is really absent in classical context. It says that with reference to the superposition principle, if both the slits are open, then the total probability is not equal to the summation of individual probabilities, that is P1 plus P2, but rather it contains another term, that is psi1 star psi2 plus psi1 psi2 star, as given by question 6. Of course, we need to learn that while discussing a superposition principle in terms of two-slit experiment with electrons, the third part of the experiment leads to the fact that total probability never comes out as on classical thinking, and we also take note of the thing that the probabilities are simply multiplicative. Had it been a classical context, we will talk about intensities, where the total intensities when both the slits will be open will be given by P equal to P1 plus P2. So this is quite can be explained with the help of this diagram, where these two slits are open. Here electron beam is coming, and if only this slit 1 is open, the probability is associated with psi1 only, psi2 is 0 in that case. If this slit is closed, this slit is open, then probability is associated with psi2, so probability is psi2 squared, and which is represented by figure number B and C here respectively. And according to on the classical context, if both the slits are open, then classically we can say that the total probability will be like this. But of course, in classical kind of thing, probability is not present there. We have only intensities. So talking about intensities, the intensity will be the summation of both the intensities coming out of slit 1 and 2. But in quantum mechanical superposition principle, when both the slits are open, the probability variation is this, like this, where there is one part present, this part, this psi1 star psi2 plus psi1 psi2 star, this part is present whenever we talk about superposition principle in quantum mechanics. So with all this, I'm ending up this video. Thanks for watching. Keep watching our videos. Never forget to comment on our videos.